Today we are tasked with finding the equation of a plane given a point it passes through and a line of intersection of two different planes. So to start off, we first just need to find the normal vector of these two planes, which this isn't a 0, this is supposed to be a 1. The normal vector of any plane is just found by the coefficients attached to each variable. So for the first one, it is going to be the coefficient 1, 2, and 3. And then for the second one, it is going to be 2, -1, and then 1. And then to find the cross product, it's fairly simple. 2 minus 1, 1 equals. So we start with I, cover up the I row. So we have 2 plus 3, which comes from subtracting this -3 right here, these two. And then for j, always subtract j, cover up the j row, 1 minus 6, j hat. And then k is just the vice versa of I, so starting with this one, we have -1 minus 4k. And then we just need to simplify this, minus -5j minus 5k, which this is just +5. Let's erase this and hopefully not erase the bottom. Okay, well, now let's just move this up. So now that we have the cross product of the two normal vectors, we can now move on to finding the vector between P and Q. So now we're looking for this vector. And to do that, we first need to find the point Q, or the intersection from these two planes. And we just simply need to set up a system of equation with those two planes. And to make this simpler, let's begin by setting z equal to 0. So if we set z equal to 0, q will be 0. And then we can just get rid of these two terms. Equals 1 equals -3. Okay, then you just have to solve this. So x equals 1 minus 2y. And then 2 times 1 minus 2y minus y is going to be 2 minus 5y. So y is going to equal to 1. That's not where y goes. 1. And then for the first part, we just add that y equals 1 back to here. So x plus 2 equals 1 minus 2. So x equals -1, -1. So then, now that we have q, we can find pq, which is found by subtracting q from the value p. So let's do that quickly. So we have -1 minus 2, and these are the values coming from this point p, comma, 1 minus 3, and 0 minus 2, which is equal to -3, -2, and then -2 again. And then we can simply plug these back up here. So -3, -2, -2. And get rid of the point Q. So now that we have this vector PQ and we have the cross product of the normal vector of the two planes, we then have to find another cross product between these two. And to do that, we set up the matrix and then add these two. Those are supposed to be 5s. My handwriting is not too great. Okay, and then we just find the cross product again. So this would be -10 minus 10i. And then subtract the j, cover up the j, which would be -10 minus 15j. And then add the k, which is -10 plus 15k, which simplifying it is 20i hat plus 25j hat plus 5k. And then when it comes to normal vectors, any scalar of the normal vector, where we'll say that t is a scalar, is going to be equivalent to the original normal vector. So we can divide all these by 5, so we are left with -4i plus 5j plus k. And now that we have the cross product between this cross product and the vector, we can now find the equation of the plane, which involves taking the original point we had and just plugging it into this equation. So -4 with the first position of the x, which is x minus 2, which is coming from this one, plus 5, y minus 3, coming from this one, plus 1, z minus 2 is equal to 0. And then we just simply have to simplify this equation and hopefully not get our signs wrong, because this can get a little confusing. And we're just going to separate these variables to make it a little simpler. Plus 8 minus 15 minus 2 equals 0. So this will be 6 minus 15, which equals -9. So these equal -9, and they're equal to 0. So then we just have to move this one over here, and we're left with -4x plus 5y plus z is equal to 9. And this is the equation of the plane which passes through P232 and has a line of intersection of those two planes.